Awesome. What's up, guys? This is Matt with MonsterVR again. Doing C# learning. Let me get to Unity. I'll maximize that. And we got Visual Studio as well. Cool. So let's get into C# learning. I'm using this book called Learning C# Programming with Unity 3D by Alex Akita. And we're just doing small chapters and small projects just to kind of cover the fundamentals. I have to learn this stuff anyway, so I might as well videotape it. So anyway, today we're going to go over chapter 4.10. It's called Turning Ideas into Code, Part 1, and we'll see where it goes. So when you need to take a task and turn it into code, you need to start off with the first action taken by the player and turn that into something that the computer can use, or rather collect incoming data and then process it. Often when this is the input needs to be recorded and dealt with in a meaningful way. If your primary form of control involves mouse and keyboard, then it's best to start by making sure you can read both the mouse and keyboard inputs. If you're using a touch screen, let me get over here, perfect. If you're using a touch screen, then you need to make sure you can read where and when touch input happens. When using Unity 3D, you've got the input class to start with. Everything you need will be found in there. Ooh, the input class. Let's open up Visual Studio real quick. Boop. Perfect. More behavior. Blah, 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 start function, good. All right, to follow along, start with the Ideas Part 1 project from downloaded projects file provided in here. We'll look at the example CS, blah, blah, blah. All right, now MonsterVR makes looking for the code you need easier by guessing what it is you're looking for. Start entering the word input, and then MonsterVR guesses what class it is you're going to pull from. So input. See, it starts going. I think it's going to be right here. Start entering the word input, and the MonsterVR guesses what class it is you're going to pull from. If you are unsure where to start looking, a search through a web search engine is a good place to start. Chances are the question you have in your head has been asked on a forum and answered in some way, often with some code to help you towards your goal. A simple Google search for Unity 3D, how do I read the keyboard, takes you to either the Unity 3D online documentation or answers.unity3d.com. Either of these pages will at least give you a clue or two about what function or class to look at. Say for a moment we want to read the mouse movement. To check we are able to do this, we'd able to use the print function to see what sort of data we'd get from the input class. So we'll go and void update. They want to do a debug.log. By the way, I heard Unity is now with Visual Studios, and I've never used Visual Studio, and it is awesome. It looks great so far. So I'm really curious how this is going to affect my development. But I've heard nothing but good things. Oh, .log, and then we'll do an input thing right in the parentheses. And input right there. Perfect. Not like that at all. What's going on? Input dot. Okay. It says location, mouse position, and oh, cool, it's a bunch of different things. The closest thing we're able to find, which might lead to a mouse position, seems to be input mouse position. So let's go input dot mouse position. Excuse me. the input.mouse position returns a vector3 type variable. A vector3 is made of 3 parts: a float, x, y, and z value, and we can expect that it is related to the input in some way. To find out what the values, to find out what values the input.mouse position returns, we can use the debug.log input.mouse position entered into the update function of the example found in provided project. To make sure that the update function is called, we'll attach the example to the main camera in the empty scene. So we'll go. We have this. This looks good. I don't know. I think I need a semicolon here. There we go. All right, cool. Looks good. We'll do a Control S. Save that bad boy. Go to main camera, where we have our script. Cool. Go to console, and we hit play. See what happens. Ah, there it goes. See? Putting up all of the where the mouse is located every frame. It's pretty cool. Alright. There we go. Alright. While the game is playing, the first and second values printed out to the console window in Unity 3D change when the mouse is moved. The connection between the mouse and the value returned by input.mouse position makes sense, but how do we use this to control a camera or even a character? We get 2 fairly big numbers which represent some point on the screen. Yeah, basically all these big numbers, 552, 55225. Turning the data from input.mouse position into something we can use to move a character or camera for a game that requires a bit of manipulation. Before we start using the input.mouse position values, we need to decide what we're going to do with them. In a classic FPS, the camera is always under the control by the mouse. Therefore, we should start by doing the same. With the script attached to the camera, we can help to manipulate various aspects of the object that the code is attached to. In a new Unity 3D project, we should have the example CS attached to the main camera in the scene. This will allow us to manipulate the camera with mouse input. It's cool. Alright. So this is what they want me to throw in here. So we'll go back to Visual Studio. Alright. Void start. Void update. We're going to do. I'm going to get rid of this. And we're going to go transform dot rotation. See, it already has it auto configured. Equal to quaternion dot u.
What's going on, sir?
Let me see. 1 second here. Just doing the video. Alright, we'll put in a new.
Sweet.
New vector 3.
Excellent.
Input dot rotation equal to. Oh wait, I have that wrong. Go back. Vector 3. Input dot mouse position. I was looking at the wrong mouse position. Mouse position dot x. Input dot mouse position dot y and I'll do looks pretty good. Control S. All right. To get started, we'll use a single line of code in the update function. The line transform.rotation is equal to quaternion.euler new vector 3 input.mouse position x input.mouse position y, and I'm guessing this would be like the z for, but we're doing it for 0, so we're not using it, is a long line of code, and it doesn't quite work how you might expect. When you add a few objects into your scene and move the mouse with the game running, you'll see that the camera is indeed spinning around and the mouse is rotating the camera's point of view. However, the behavior isn't exactly the same as that of an FPS. Let's run it and find out. Ah. Yeah, not quite. It's close. It's a little weird. No control. Whoa. Alright. Let's go back to the code. This is a start, and you might be able to see how quickly we can begin to manipulate objects in a game with familiar systems. However, the refinement to get from here to a full-blown first-person controller takes much more than one line of code. Even so, there are many things to explain in that single line. No doubt there are many questions you might have as to what's really going on here, and that's good. We will learn what all that means, but one thing at a time. We still have many different terms to figure out before we get to that. If we take a step back from mouse input, we would ask the following question. What is the rotation of the camera? Rotation data is easily accessed by any script attached to the camera object in the scene. But why? When a script is attached to an object in Unity 3D, it becomes a component of that object. Classes, as we know, can be created as an aggregate of other classes. An object is created from a blueprint, or rather a class. That process of creating an object from a class is called instantiation. And by adding a component to a game object in the Unity editor, we're providing Unity 3D with game object construction information. Thus, info is used to instruct Unity 3D what objects to instantiate for the game object. Specifically, in code, the C# file you attached is instanced by the game object when the game starts. As a matter of fact, practically every object in a Unity 3D scene is a game object. The camera, lights, boxes, and so forth. Everything you see in the scene is a different instance of a game object class, each one with different attachments. Everything you see, so basically, this directional light, game object. Main camera, game object. Everything you see in the hierarchy panel is a game object. They're all on, oh wait a minute. Oh yeah, everything you see in the hierarchy panel is a game object. They're all instances of the game object class found in the Unity engine library. This point is significant because this means that Unity 3D has done some automatic code generation for you. This is, of course, what a game engine is supposed to do. The Unity 3D engineers put a great deal of work building tools with a pretty user interface, which is this nice, beautiful thing. And these are all like tools and so forth. As a level of designer, you're able to manipulate your values in your code while the game is running. Game object is made up of several other classes. You can see what other classes are being used in the game object when it's selected. So you can see right here. Game object is made up of several other classes. Yeah, these are all classes of game object. You can see what other classes are being used in the game object when it's selected. The inspector panel shows you some of the classes that are a part of the selected game object. The transform, the mesh filter, so the transform, the mesh filter, I don't think they're on this one. I don't think the camera has a mesh filter. Box collider and mesh renderer are all classes that are all members of the game object in the scene. To dig another level deeper, transform has position, rotation, and scale as data members. Right here, transform, the class transform has position, rotation, and scale. as its data members. Each other class listed in the inspector panel has data members as well. For every script you add to each game object, you're adding new data members to the game object. So to a certain extent, when you add objects to the scene, you're adding code to the scene. When you attach components to a game object, you're writing code to instantiate your class in that game object. At all levels, every action you take in Unity 3D is calling some class function or manipulating the data of a member of a class. This goes to the same for every piece of software you use every day. It's all code. This might seem somewhat existential, but it's to our advantage to understand that a game object is a class. Every time we add our code as a component, we're telling game object to instantiate our class. Once instantiated, yep, that's it. Our code has become a part of the Unity 3D scene and can both read and write data to the scenes in it. Once we get a better grip of the rest of the terms required for writing code, we'll start adding and removing objects in the Unity 3D scene. But for now, just get used to the idea that everything you do is simply executing some code in Unity 3D. What we've learned. I guess that's the end of the chapter. What have we learned? Figuring out what we have to work with is pretty simple. MonsterVR, which actually is now Visual Studio, assists in various ways, from telling us when we're done something wrong or what might break, like running an error function in here, or a warning. Something wrong or might break. Visual Studio also provides us with plenty of clues to help us figure out what options we have so far as functions and classes are concerned. Learning the tricks required to make these clues into functions which do what we want takes a bit of learning and practice. Asking the right questions on forums will get us so far. By spending time to learn how to use the data, we have and how to apply the data through logic, we will be able to accomplish quite a lot on our own. To learn how to do all those things takes time and effort. It's also a good idea to do plenty of research on your own before asking for help. Many problems have already been solved in many different ways. It's up to you to find the ones that you can work with. Cool. So that's it for today. Once again, my name is Matt with MonsterVR. Come back. The next chapter will be 4.11, Logic and Operators. So thanks again, guys, for watching, and I'll see you soon. Bye.